Hello children, we have completed the chapter motion and today we will start the new chapter, that is force and laws of motion. So in this chapter we will study about the force and three laws of motion given by Newton, first, second and third law. So first of all we start with the topic force. In the previous chapter, in motion, we have studied about speed, velocity, acceleration, uniform motion, non-uniform motion, circular motion. All these are studied in the chapter motion. But we don't know why this motion is caused. What is the cause of motion? Why an object which is at rest starts moving? We all know when we push an object or pull an object, it changes its position. So in physics, in simple two words, we can say the force is a push or a pull. So this way we can define force in physics by simple two words. A push or hit or a pull is the force. So this is the simple definition of force. So what is the simple definition of force? A push or a pull. We will give one more definition, but this is the simplest motion. There were two scientists, Galileo Galilei and Isaac Newton. Both of them, they first of all described the concept of force by giving these words pull and push. Before them, it was a puzzle how the motion is caused, why a moving body is stopped, why a resting body is moved. So only Galileo Galilei and Isaac Newton, they were the first to describe force in simple terms. So this is the definition, the simple definition of force. So we can explain it by giving some very simple examples we have in our day-to-day life. Suppose this is a ball. I push this ball from this side, it was at rest first. When a push is given, it starts moving in this direction and now the ball is at this place. If more push is given, its speeds increases and now it is at this position. Suppose it is being stopped by a force here, it will stop. So this push to the ball is a force, and by force its position from rest is changed to motion. Now it is moving in the direction of the force. So this is how pushing, or suppose a box is there, a boy is pushing this box, and when he pushes the box, it moves further. Again, by push, the box is moving. What are the examples of pull? Suppose a drawer is there and this is the handle of the drawer. We want to open the drawer, then by pulling this handle, the drawer will be opened. Or if we want to open a door, then by pulling the door it will open. We want to close it, by pushing it, it will be closed. So these are different examples of push and pull where the body can set into motion or a moving body can be stopped. Other examples are a horse cart. All of you have seen horse cart. Suppose this is a cart and this is the horse. This horse pull the cart with a force towards this side. So this is the example of pulling. Or we have a toy car and a string is attached to this toy car. When a child pulls this string, this car moves in this direction. So by pulling, the car is moving, which is addressed before, a toy car. So these are all examples of push and pull, and this push and pull is force. Now force is a vector quantity. All of you know what is vector? Vector is which has both magnitude and direction. The opposite, the other type of quantity is scalar quantity. Scalar has only magnitude, as you have studied about the speed and velocity. Velocity is scalar, vector, as it has magnitude and direction both. So the force is also a vector quantity and it has a magnitude, that a numerical value, a value, and direction also. If we push a box in this direction, the direction of the force is in this direction. If we stops a moving thing from this direction towards left, then the work done is negative and the force is also negative. So force is a vector quantity and it has direction and magnitude both. Now about the SI unit of force. The SI unit of force is Newton, after the name of the scientist Isaac Newton, and it is symbolized by capital N. And now we will also, I have given you the formula for calculating force. It is very simple. Force is equal to mass times acceleration. Force is equal to mass times acceleration, and we denoted by F, mass by m, and acceleration by a. And what are their SI units? Force SI unit, as I have told you, is Newton, mass is kilogram, and acceleration meter per second square. So according to the formula, suppose I want to describe 1 Newton force. So what will be the definition of 1 Newton force? When from this formula we can derive the definition of 1 Newton force. If mass of 1 kilogram is accelerated by 1 meter per second square, then the force applied will be 1 Newton. So from this formula we can define 1 Newton force. Again I am saying, when the object is of 1 kilogram, it is accelerated by 1 meter per second square. By applying the force will be 1 Newton. So by these SI units, it looks like that the SI unit of force should be kilogram meter per second square. Kilogram meter per second square. This is the unit of force, but not the SI unit. The SI unit is set as Newton. This is also the unit of force, kg dot m meter per second square, but the SI unit is Newton. So this is about the formula for calculating mass, and the derivation of this formula we will do in the next video when we will study the Newton's law of motion. But here only the simple formula, very simple formula. This is the general formula for force. There is a special formula in relation to weight and gravity of the earth, but that we will discuss later. But this is the simple formula. F is equal to m into a, mass into acceleration of the body. So with this formula we will calculate all these numericals later. So after this, I will give you the types of force. There are broadly two types, we can say. One is contact force and other is force at distance, or we can call it a non-contact force. So these are two types of force. Contact, as we know, it may be pull or push or maybe punching or wrestling, where the two objects, they are in touch with each other. If we want to pull a drawer, we have to touch the handle. If we want to push a ball or a box, we have to push it by our hand, muscular force or any other force. Then punching, we have to punch the punching bag with hands. And wrestling, when the two wrestlers, they fight, then they have to touch the body of each other. So when there is touching of the two objects, then it is known as contact force. Now the non-contact force, there are some forces which work even without touching each other, without coming in contact with each other. So one very common, all of you know, gravitational force. Gravitational force. All of you know about the dropping of apple when Isaac Newton was sitting under an apple tree. So due to the gravitational force, the apple is coming down, or a ball from a top of a roof, it comes down due to the gravitational force without coming in contact to each other. So these forces are force at distance, like the gravitational force, or the second is magnetic force. Suppose this is a magnet, this is north-south pole, a pin, an iron pin is kept near this. So this magnet will attract this pin without touching it. So a magnetic force is exerted on the iron pin and it is being attracted towards the magnet. So this magnetic force is again a force at distance. The other important force is force between protons and electrons. All of you know electrons are negatively charged, protons are positively charged. So this force is known as electrostatic force. The charged ions, the oppositely charged particles, they attract each other. All the particles of the same type, they repel each other. So this electrostatic force is also an example of non-contact or force at distance. So this is about the types of force. Now we will discuss about the effect of force. What effect does this force has on different objects? So we will discuss about 5 effects. The first is force cause a resting body to move. That is, movement or the motion can be started on a resting body if force is applied. This is the first effect. We had discussed this. Second, force cause a moving body to come to rest. When a force is applied from the opposite direction, then the moving body, it comes to rest. The third effect is velocity can be increased by applying more force. By applying force. So, velocity can be increased. Third, velocity can be decreased by applying force. So that is, change in velocity is there, and when change in velocity is there, then it causes acceleration or retardation. So force can cause acceleration and retardation, and the common examples we have studied in the chapter motion. If by the force of engine, if accelerator is pressed, then by the force of engine the car moves faster, its velocity increases, and by the force of brakes which are in the opposite direction, the car slows down or causes retardation. So the force of anything of engine causes car to accelerate or to retard. So this force, velocity can be increased or velocity can be decreased. Now the fifth one, force can change the dimension. Dimension means shape of the body. So by applying force, suppose I have a ball. Suppose this is a ball. If we press this ball like this from both the hands in opposite direction, if it is a soft ball, then it will pressed and its shapes changes to oval, like an spring. Suppose this spring is there. If force is applied on this spring by both the sides, from both the sides, its dimension changes. It becomes, you can see, it becomes smaller. So by pressing this spring, or by stretching this spring, the dimensions again changed and its length is increased. So this force can change the dimension or shape of the body. One more is there. Force can change the direction also. Direction of the body also. Suppose this is a ball and it is moving in this direction. I hit the ball or push the ball from here, the direction will be changed to this. So force can change the direction also. So these are the effects of force. Now one more definition of force is, I am writing on the board. The simple one is a push or a pull, and a better one or a fancy one or a decorative one. The definition of this force is, it can change or tends to change the state of rest or motion of an object, and can change its dimension also. As we have discussed in effects of force, so this is the definition, that force can change or tends to change the state of rest or motion of an object. If the body is at rest, by force it can move. If it is moving, by force it can be stopped and can change its dimension, as we have seen with this spring. So this is the definition of this force. Now we will see if two or more than two forces applied simultaneously. It means if one force is applied, the body moves in the direction of the force. But if two or more than two forces are applied together, then what will happen? If two or more forces they are applied together, they are known as balanced force and unbalanced force. These are two types of force which are due to application of two or more force together. First, we should know the net force here is equal to 0 and the net force here is not 0. What does it mean? Net force is 0 but net force is not 0. Suppose this box is there and a force of 5 Newton is applied on this box from this side, and from the opposite side also a force of 5 Newton is applied. Then what will be the net force? 5 minus 5 is equal to 0. The net force will be 0 and the box will not move. Why it will not move? Because from both the sides the same force is applied and it is a balanced force. So due to the balanced force, the box will not move. Now we will see on this side the same box is there and from this side 10 Newton force is applied. From this side 5 Newton force is applied. What do you think? The box will move or not? Yes, it will move in this direction where more force is there, as the net force is 10 minus 5 is equal to 5 Newton. So box will be moved in the direction of the greater force. So this is balanced and unbalanced force. Second is, or we can have many examples. Suppose this is the box, from the four sides equal forces are applied, then box will not move because this will cancel this and this will cancel this. But if the forces are of difference, it is greater, it is smaller, then the box will be moved in the lower direction. So this is how balanced and unbalanced forces are there. This is 0 and this is not 0. The second is, in balanced forces, the dimension, as we have just seen, dimension can be changed by balanced forces. How? As I have just shown you, if this is the spring, so from both the sides the same forces are applied whose net force is 0. So the dimension is changed, and suppose I put this like this also, by pressing, the force from both the side is same and again the dimension is changed. So by the balanced force, dimension can be changed. Or suppose we have this balloon. We press this balloon from both the sides with equal force, and now the balloon will be slightly oval. Due to the applying of force, the dimension is changed. So balanced force can change the dimension also. While unbalanced force, the force of friction is also an unbalanced force. What is friction? Suppose force of friction is also under unbalanced force and it causes the moving bodies to stop. Suppose this is a plane surface and a ball is put here and it is pushed. So pushed hard and it starts moving in this direction. Only one push is given and after some time this ball it stops going through a certain distance. Why this is stopped? Because the force of friction which is in opposite direction is an unbalanced force which acts on the force of the moving ball and it causes stoppage of this ball after some time. This is the force of friction between the ground and the ball. So this force of friction is unbalanced force. Suppose this surface is very smooth and there will be no force of friction, no unbalanced force, then this ball will move forever. It will not stop because once it is pushed, it has some force, it is moving. Unless it is being stopped by some other unbalanced force, it will go forever, it will move forever. So friction is an unbalanced force. The other example we can see by taking the example of a bicycle. I cannot make bicycle good. Suppose this is a bicycle. If a cyclist it is pedaling the bicycle, he goes on moving. There is the force of friction of the road is there, but he goes on moving because the force of pedaling is more. It is an unbalanced force. But if he stops pedaling, then after some times the bicycle will be stopped. Why it will be stopped? Because now the force of friction is working on the bicycle and it causes the stoppage of bicycle. So these are some balanced and unbalanced forces. Now I have given you the formula also. Now we will try to calculate these very easy numericals. Take a screenshot, try to do by yourself. Now read the first one. So first of all, we will write the formula of force. F is equal to ma, where m is mass in kilograms. Remember, the SI unit of mass is kilograms, not grams. So if grams is given, then you have to convert those gram by dividing it by 1000 to kilograms, because the SI unit of mass is kilograms, not grams. This is meter per second square, this is Newton. So mass of 3 kilograms, so F will be 3 into acceleration is 3 meter per second, very simple, 9 Newton will be the answer. What is the magnitude and direction of the force? The magnitude is 9 meters and the direction is in the direction of the movement of the body. 3 kilogram is accelerated, so it is on the right hand side because acceleration is done. So in the direction of the motion, so this is the magnitude and the direction is in the direction of motion. So this is the answer of the first. Now the second, what is the acceleration of a ball? Here acceleration is asked, so we can write the formula for acceleration from here. A is equal to F by m. Mass is 200 and force is 3N. So force 3n, and mass is 200. So first of all, 200 grams, they are converted to 200 upon 1000 kilograms. So 200 upon 1000 kilogram. This m is in denominator, so we will write 200 into this. So this will be 30 by 2 or 15 meter per second square is the acceleration caused by this force. So this is the answer. Is it clear? 200 grams converted to kilogram, 200 upon 1000. This m is in denominator, so 2000 will be written in denominator, 1000 in numerator. So this will be the answer. Now what is the third? A force is applied to change the velocity of an object from 5 to 10 of mass 500 grams. Again, we will write the same formula. Here acceleration is not given, but the velocity, change in velocity is given and time is given. All of us know that A is equal to V minus U upon T. This is the formula for acceleration. So instead of A, we will write F is equal to M into V minus U upon T. Now we will put the values. What is the mass? Mass is 500 upon 1000. We have to convert it into kilogram. Then V is how much? From 5 to 10. The final velocity is 10. Initial velocity is 5. Time given is 5 seconds. So this will be like this. So 1 by 2 into 5 upon T is 5. 5 upon 5. This will be cancelled. 1 by 2. F is 1 by 2 or 0.5 Newton. So instead of acceleration, change in velocity is given and time is given. So we will calculate acceleration like this. This is the mass. So the force will be half Newton or 0.5 Newton. So what about the fourth? These are very simple numericals. The fourth is a body of mass 2 kg accelerates in 5 seconds from rest. Again the velocity is given when it is pushed in a straight line. Magnitude of push is 2n. Magnitude of push means it is force 2n. What will be its final velocity? Again the same formula, ma. Instead of a we will write v minus u upon t. M is given 2, mass is given 2 kilograms, and v is asked and u is rest. When something is rest, it means the velocity is 0. The time given is 5 seconds. 5. So it will be 2v upon 5. F, how much F is given? 2n. So 2 is equal to 2v upon 5, or 2v is equal to 5 into 2, v is equal to 5 into 2 upon 2, or v is 5 meter per second. So here the final velocity is 5 meter per second. So this is how these simple numericals are solved. This is all about force. In the next lecture, we will study about the laws of motion. Thank you.